So in this lesson, I'm going to be showing you how to solve inverses of rational functions. So a brief recap before we go on, when you're solving inverses algebraically, it basically means that you're switching the x and y values in the equation. And if you're solving for inverses graphically or using any sort of graphs, you're going to be looking for a reflection over the line y equals x. And just to remember that the domain of the original function will become the range of the inverse and vice versa. And you can determine if two functions are inverses by using composition, which basically means that you'll be solving to see if both equations equal x. So for the steps to solve for an inverse of a function, you're first going to replace f of x with y. Then you're going to switch the x and y values in the function. Then you're going to solve the equation for y. And then once you've solved the equation for y, and once the equation is set up as y equals, you're going to replace the y with f inverse of x. So for our first example, we're going to be solving for the inverse of f of x equals 2 over x plus 3. So the first thing we're going to need to do in our equation is switch f of x with y. So this is going to give you y equals 2 over x plus 3. Then the next step in our equation is to switch the x and y values. So this is going to give you x equals 2 over y plus 3. Then to solve our equation for y, we're going to have to get rid of the fraction. So we're going to have to multiply both sides of the equation by y plus 3. And this is going to give us xy plus 3x equals 2. Then as we solve this equation, we're going to have to get y by itself. So the first thing we're going to need to do is get all the x's onto one side of the equation. So first we're going to start by subtracting 3x from both sides. And this is going to give us xy equals negative 3x plus 2. And then all we're going to have to do is divide x from y. And this is going to give us y equals negative 3x plus 2 over x. And then the last step we have to do is replace y with f inverse of x equals negative 3x plus 2 over x. And then the last step in our equation after finding the inverse is to find our domain and ranges. So if you remember from the steps before that the domain of the original is going to become the range of the inverse. So the first thing we're going to do is find the domain of the original function. And you can do this by setting the denominator equal to 0. So if we do set our denominator equal to 0, you're going to find that it equals negative 3. And this is going to give you what x can't equal. So our domain is going to be all real numbers except x cannot equal negative 3. And then if we find the domain of our inverse function, which is by setting the denominator to 0, we're going to see that the domain is all real numbers except x cannot equal 0. So then if we plug in the domain of the original as the range of the inverse, you'll get that the range of the inverse is all real numbers except y cannot equal negative 3, and the range of the original is that the range is all real numbers except y cannot equal 0. For our next example, we're going to be seeing if two functions are inverses of one another, which means that we're going to be solving both equations for x. So for this example, we're going to be working with two functions. We're going to be working with f of x equals negative 11x plus 6 over x plus 6, and g of x equals negative 6x plus 6 over x plus 11. So for the first half of our problem, we're going to be finding f of g of x, which means that we're going to be plugging in the g of x function into any of the x values in the f of x function. So first we're going to start out with plugging in the g of x function into the f of x equation. So this will give us f of g of x equals negative 11 times negative 6x plus 6 over x plus 11 plus 6 over negative 6x plus 6 over x plus 11 plus 6. Then, like before, to get rid of our fractions in our function, we're going to have to multiply the numerator and denominator by x plus 11. So by distributing this into the function, we're going to see that the x plus 11 cancels out in both fractions, and you'll get that negative 11 times negative 6x plus 6 times x plus 11 over negative 6x plus 6 times x plus 11 is our new function. Then once we distribute all our values, we'll see that the equation equals 66x minus 66 plus 6x plus positive 66 over negative 6x plus 6 plus 6x plus 66. Then, as we're adding all our values together, we'll see that negative 66 and positive 66 cancel out in the numerator, and negative 6x and positive 6x cancel out in the denominator, and this gives us 72x over 72, and we'll see that f of g of x equals x. So since this function equals x, we can go on to solving for g of f of x to see if it also equals x. So like before, we're going to start out by plugging the f of x function into any of the x values in the g of x function. So this will give us that g of f of x equals negative 6 times negative 11x plus 6 over x plus 6 plus 6 over negative 11x plus 6 over x plus 6 plus 11. And as before, we have to get rid of the fractions in our function, so we need to multiply the numerator and the denominator by x plus 6, and this will cancel out the x plus 6 in both of the fractions, and will give us negative 6 times negative 11x plus 6 times x plus 6 over negative 11x plus 11 times x plus 6. Then once we distribute all of our values, we'll see that the equation equals 66x minus 36 plus 6x plus 36 over negative 11x plus 6 plus 11x plus 66. Then as we add all our values together, we'll see that negative 36 and positive 36 cancel out in the numerator, and negative 11x and positive 11x cancel out in the denominator, and the function comes to equal 72x over 72, and we see that the g of f of x function also equals x. So since both of these functions equal x when we plug one into one another, we see that they are actually inverses of one another. And that's it for this lesson.